Chem 1251 pre-lecture video. Nomenclature. Chemical nomenclature is the manner of assigning names to chemical substances. When a name is assigned to a molecule, we have a specific representation of the molecule's formula. The name we assign can tell us information about the molecule's chemical and physical properties. The names identified to molecules, therefore, create a common language to allow communication for chemists and for others who deal with chemicals. If we can classify the molecule into the correct one of two groups, it will be much easier to determine a name for the molecule. The groups we will focus on are molecular compounds, those which are made of two nonmetals, and ionic compounds, those with cationic metals and anionic nonmetals. Organic molecules, which typically have more than two nonmetals, have a very specific system of nomenclature that's beyond the scope of this course. Molecular compounds will be composed of two nonmetals. Nonmetals are located on the right-hand side of the periodic table and are shaded blue in this image. Now that we can identify nonmetals, let's see how to name the compound whose formula is NO2. Our first step will be to identify whether we have metals and or nonmetals. Our formula contains nitrogen and oxygen, both of which are nonmetals. Second, we must determine which Greek prefixes are needed to name our molecule. When our first atom has the understood subscript of 1, we typically do not include the prefix mono. However, all second atoms in a molecular compound require a prefix. Since there are two oxygen atoms present, we will be using the prefix di. To review those steps, we first identified that our formula contains nitrogen and oxygen, both of which are nonmetals, so this is a molecular compound. Second, we determined that mono is not needed for N, our first element, while two oxygens correspond to the prefix di. Third, we name the first element. N is the symbol for nitrogen, thus the molecule name begins with nitrogen. Fourth, name the second element with its IDE form, remembering to use the appropriate prefix. Oxygen becomes oxide, so with two oxygen atoms, our second element will be named dioxide. Finally, combine each of the two names together to obtain nitrogen dioxide. Note that, like any other noun, the N in nitrogen dioxide is capitalized only when the compound is listed at the beginning of a sentence. Let's look at more examples of molecular compounds. Our first goal is to name the molecule S2F10. S is the symbol for sulfur, and F is the symbol for fluorine, both of which are nonmetals. Since sulfur has a subscript of 2, we will use the Greek prefix di with sulfur. The prefix corresponding to 10 is deca, similar to decade, which corresponds to 10 years. 2 sulfur atoms gives disulfur, and 10 fluorine atoms gives decafluoride, hence S2F10 is named disulfur decafluoride. We can develop a similar step-by-step procedure to convert a given name into a formula. Let's try to obtain the formula for tetraphosphorus hexoxide. Phosphorus is a nonmetal, and oxide corresponds to oxygen, which is also a nonmetal. Tetra corresponds to 4, and hex corresponds to 6. The reason why hex is used instead of hexa is to make the pronunciation smoother. So we obtain P4O6. Note that these numbers are used as subscripts after each element in the formula. Naming ionic compounds differs from molecular compounds. Ionic compounds are always named with the cation followed first by the anion. Some cations can have more than one charge, however. Those cations are almost always transition metals. But for now, let's focus on cations with a single positive charge. Both alkali and alkaline earth metal cations are single charge, and those charges correspond to the group number. Alkali metal cations are always 1+, and alkaline earth metal cations are always 2+. There are also a few special cases. Silver will always be 1+, both zinc and cadmium will be 2+, and aluminum will be 3+. One commonly encountered polyatomic cation is ammonium, NH4, which has a charge of 1+. We need to commit to memory these cation charges in the red box. Let's look at the procedure for naming the molecule whose formula is CaF2. Since we have a metal and a nonmetal in our formula, our molecule will be classified as ionic. Ca corresponds to calcium, a group 2 alkaline earth metal, and F corresponds to fluorine, a group 7A nonmetal. Since calcium is the metal, and it always has a 2 plus charge as an ion, we name that first. In our formula, fluorine is considered to be a monatomic anion, and we will use the IDE ending with fluorine, so fluoride. Combining the cation and anion gives calcium fluoride. Notice that when naming ionic compounds, we do not use Greek prefixes. Whenever we have a cation that can have more than one possible charge, these are usually transition metals, as well as the heavy metals tin, Sn, mercury, Hg, and lead, Pb, we need to specify the cation's charge in the name of our compound to avoid ambiguity. The way we do this is to use stock notation. The format is to name the cation element name first, and then, in parentheses, to use capital Roman numerals to indicate the cation's charge. Let's use the formula Fe3 parentheses PO4 and parentheses 2 as a representative example. Fe is the symbol for iron, and we know that iron can be 2 plus or 3 plus by looking at the periodic table on this slide. So, we've determined that Fe3PO42 is ionic because Fe is a metal in a compound, and Fe can have different charges. Since we treat Fe as having a charge, PO4 must also have a charge. PO4 is a polyatomic anion whose net charge is always 3-. Whenever we have a cation that can have more than one possible charge, it is best to work backwards, starting with the polyatomic anion, to determine the cation charge. In order for our compound to be neutral, the total cation charge and the total anion charge must balance. They must add up to 0. The polyatomic anion is called phosphate, and there are 2 phosphate units in our formula. Thus, the sum of the anion charge is -6. So, our total cation charge must total 6 plus. That means that each iron atom will have a charge of 2 plus because 3 times 2 plus is equal to 6 plus. Just like the previous example, we named the cation first. However, we'll use stock notation in this case to indicate the charge on each cation. Thus, we have iron 2. The anion is named phosphate, and so our compound is named iron 2 phosphate, with the 2 in Roman numerals in parentheses.